Hello and welcome to the session. In this session we will discuss probability distribution for a random variable defined for a sample space in which probabilities are assigned empirically. We know that probability is the study of randomness. It is the measure of likeliness that a random event will occur. Now we will discuss empirical approach of probability. The empirical approach of probability is that of relative frequency, that is, the ratio of the total number of occurrences of an event to the total number of times the experiment is repeated. That is, probability of an event E is equal to frequency of event E whole upon number of trials of an experiment when the number of trials are large, then the relative frequency gives a satisfactory measure of the probability associated with a particular event. Empirical probabilities are determined by making observations and gathering data, or we can say that empirical probability estimates probability from experience and observation. For discrete random variables, the probability distribution of a random variable capital X is the assignment of probabilities to the values of capital X. If capital X is a random variable, with possible values denoted by small xi, and probability of small xi denotes probability of capital X is equal to small xi, that is, probability distribution then expected value of capital X is given by E of capital X, which is equal to summation of small xi into probability of small xi, where I varies from 1 to n. Let us take an example. The number of heads, that is capital X, that come up when a fair coin is tossed 5 times is a random variable. The probability distribution of the random variable capital X is shown. Now here, total number of outcomes of an experiment of tossing 5 coins will be given by 2 raised to the power 5, that is equal to 32. And here, for getting 5 heads, we get the value of small x as 5. So probability when capital X is equal to small x, that is 5, is equal to 1 upon 32. As for small x is equal to 5, we have one outcome favorable to the event and total number of outcomes is given as 32. Now, for getting 4 heads, the number of favorable outcomes are 5. So we say that probability of capital X is equal to small x, that is 4, will be equal to 5 upon 32. Similarly, the number of outcomes favorable to the event, that is the number of heads, is equal to 3 are given by 10. So probability of capital X is equal to small x, that is 3, will be equal to 10 upon 32. Similarly, we get probability of capital X is equal to 2 as 10 upon 32. Probability of capital X is equal to 1 as 5 upon 32, and probability of capital X is equal to 0 as 1 upon 32. Now we know that the expected value, that is E of capital X, is given by the formula, that is summation of small xi into probability of small xi, where I varies from 1 to n. Here, expected number of heads can be calculated by using this formula. Here, values of capital X is 0, 1, 2, 3, 4 and 5. Also, we have found their probabilities. So, expected number of heads will be given by 5 into 1 upon 32 plus 4 into 5 upon 32 plus 3 into 10 upon 32 plus 2 into 10 upon 32 plus 1 into 5 upon 32 plus 0 into 1 upon 32, which is equal to 5 upon 32 plus 20 upon 32 plus 30 upon 32 plus 20 upon 32 plus 5 upon 32 plus 0. On solving it, we get this value as 2.5. Thus we get the expected number of heads as 2.5, or we can say that the weighted average of random variable capital X is equal to 2.5. Thus in this session we have discussed probability distribution for a random variable defined for a sample space in which probabilities are assigned empirically. This completes our session. Hope you enjoyed this session.